Hi, everybody. This is just a review video for in case you don't remember how to do naming of ionic compounds. Remember that we have this awesome periodic table resource that you can find from your classwork tab in the resources folder. There is a link to our periodic table that we use in class in case you don't have yours at home. So you have an electronic version that you can use. And what that means is that now I can go through and remind you of what we did. This is page 8 of your notes and homework packet. You can access page 8 of your notes and homework packet from your Unit 5 Ionic Bonding. And this is the notes and homework. This is starting page 8. I apologize that the focus of my HoverCam is not so great, but you have the much better resolution on Google Classroom, so you can follow along at home. So this is page 8. Remember that when we're naming ionic compounds, we do the metal name first. So this is Na, we call this sodium, and then Cl. Remember, if we get the non-metal name, becomes the IDE ending. So it becomes sodium chloride, sodium chloride. Chlorine becomes chloride. K is potassium. And S, sulfur, becomes sulfide. I'll scan these in so you can see them a little bit better. Remember, anytime it's an INE ending, it becomes IDE ending. Anytime it's an IUM ending, it also becomes an IDE ending, right? Just like in any language, the ending of the vowel changes, but the stem does not. Moving to the bottom of this page, remember we can keep track of polyatomic ions. Those are the ones on the back of your periodic table, right? The ones that look like that. Naming it works exactly the same. Na, if it's a regular element, it stays the same. Sodium. But then NO3, remember, is our family. We look up our family and it is nitrate. NO3 is nitrate. NH4 is also a family. You find that on your list, and it is ammonium. And then the second family name is SO4, ammonium sulfate, right? That's sort of level 2. The next one is if it is in the D block. If it is in the D block, right? Remember, the D block is the middle of your periodic table. Anything in the D block is a transition metal, and we need to use a Roman numeral that indicates the charge. The Roman numeral indicates the charge, so we have to figure out the charge. So copper, we find it is in the D block, so we would write copper and then leave space for a Roman numeral. S, sulfur, becomes sulfide. Sulfide, we have to figure out the charge. S normally has a charge of -2, so that means that copper has to balance it out with a charge of +2, so we put a Roman numeral 2 in our parentheses. Next one, similarly, copper, it's in the D block, so leave space for the parentheses. Cl becomes chloride. Cl has a charge of -1, so copper has to balance it out with a charge of +1 because it has to be balanced. So if copper's charge here is +1, that gives it a Roman numeral 1 in the parentheses. Zinc is also in the D block, so we give it parentheses, space for that Roman numeral to indicate the charge. O becomes oxide. Oxygen normally has a -2 charge, so that means we have to totally balance out the -2 charge with a +2 charge over here. But because there are 2 zincs, each of the zincs has a +1 charge, because 2 times +1 gives us a +2. To balance out this negative charge, -2 charge, we need a total charge of +2. But because we have 2 zincs, each one gets a +1 charge. Our Roman numeral is the charge on each zinc. +1 gives it a 1 Roman numeral. And finally, we have cobalt. Again, it's in the D block, so we leave space for a Roman numeral. Se is selenium. It becomes selenide. We need to figure out its charge. Se normally has a charge of -2. There are 2 of them, so our total charge is -4. That means our total positive charge is +4 because there's just one cobalt. It gets all of it, so it's the Roman numeral 4. Hope this is a good refresher for you. I'll give you some more helpful hints on the next couple of pages.